Hello again and welcome to my video. Today we're going to talk about the distribution of a categorical variable. And so last time we have seen how to represent the distribution of a continuous variable. This time we will see how to represent the distribution of a categorical variable. Before I get to the point of to remind you what is the difference between categorical and numerical variables, don't forget to subscribe to my channel or to put like a like if you have enjoyed the video, of course. Otherwise, don't hesitate to ask me questions to my email in the comments below. So, what is a categorical variable again? So, in a data set, we have the rows that are the participants and the columns that are the variables. And a variable can be either categorical or numerical. A categorical variable can be either nominal, so it takes names as values, like favorite animal column could be either a cat, dog, or a snail. A categorical variable, also called qualitative variable, can also be ordinal. So when there are no more than 7 levels with a meaningful order, we still classify this as a categorical variable. After 7 levels with a meaningful order, it falls in the discrete, so in the numerical variables family, okay? So last time we have seen the histogram and the box plot that are there to represent a numerical variable. This time we will explore how to just represent the distribution of a categorical variable, and this will be simpler because this is just like bar charts of counts or percents or percentages or pie charts. Okay, so we are just focusing on the categorical variables on the left hand side of this diagram. So what is the type of graph that we're going to use for representing the distribution of a categorical variable? It would be basically it would be the pie chart or the bar chart. Okay, so second row of that slide. Okay, we will either count the individuals per category in your data set. Let's say you have 25 patients and you have like blood group number 1, blood group number 2, blood group number 3. You would count the number of patients per blood group. Okay, so you would have the first bar is the number of people in the blood group 1, the second bar is the number of people in blood group 2, the third bar in blood group 3. Okay, well, in the case where we just have 3 groups, we wouldn't have these 3 last bars. We just would have 3 bars. Okay, same, we could also represent the distribution of a categorical variable. So how the categorical variable is distributed across your data set, across your patients, by a pie chart. Okay, number of people in the group blood group 1, number of people in blood group 2, and number of people in blood group 3. Although in a pie chart, we automatically represent the percentages. So when you want to represent the distribution of a categorical variable, it is actually better to use the percentages because it will give you more like the proportion of people falling in that category over the whole data set. The statistics that we use are simply the mode, so which will come back at the end of the video. It is the most frequent category, okay? If you look at the bar here, the mode would be the blood group 2, okay? Because that's the bar that contains the highest the highest count of patients, okay? So blood group 2 would be the mode of the categorical variable blood group, okay? Also on the pie chart, you can see the one that has the highest proportion. If you have 25 patients and you have like 80% who are in, I mean, not 80% in that case, maybe 30%, 35%. The other one, it would be 30% and 25%, for example. The one that has the highest proportion is, of course, the mode, okay? So let's go on. So we will just, so I use R just to represent you like the bar chart, the 2 types of bar chart, which are just for representing the distribution of a categorical variable. The bar chart that is clustered, so sorry, the stacked bar chart, sorry, not clustered. Clustered is when you want to represent two categorical variables. So sorry for this. Either you would represent by a stacked bar chart the distribution of a categorical variable, or a Dodge bar chart. Okay, we will see just that right now. So we are using the Titanic train data set. So at the moment, do not worry about the word train. We will see this notion when we start by building our first model. So usually when we build a model on a train data set, and we test our model to predict, for example, the survival on the Titanic, based on the feature that you have on the test data set. So this train data set of the Titanic data set that is in the package Titanic in R, so all the code is here. This train data set only contains 67% of all the passengers information of the Titanic. It's not the whole data set of the Titanic. So let's first represent a bar chart. So when you use the Deepler package in R, you would group the Titanic train. So you would count per class the number of passengers, okay, in the train data set. And here we have, for example, with this code, it means that we count 216 people in the first class, 184 people in the second class, and 491 people in the third class in the train data set. Okay, that's just 67% of the Titanic data set. This row here, so this data set, first of all, is created by this code. But this row is to specify that the class, the passenger class, is not a numerical variable, this one. We need to specify that it is a categorical variable. And in R, a categorical variable is a factor variable. So you need to treat this like variable P class in the data set, in the data frame, df stands for data frame, as a categorical variable, so as dot factor. Okay, I just transform my P class variable as a categorical variable. Okay, so here I have the P class variable that is here. So passenger 1. So the first row is passenger 1. He did not survive. He was from the third class. Okay, his name is this, he is a male, his age is 22, and so on. So the P class is 3. Okay, so at the minute, R takes it as a numerical variable, but you need to define it as a categorical variable. So you need to put it as a factor, okay, in order to split them to have a proper stacked bar chart like this, okay? So that is a stacked bar chart in which you have the count of the people, okay? So the third class is the mode, okay? Class number 3 is the mode of the categorical variable P class, passenger class. Well, it looks like the second class is the smallest in here. So let's say if you had treated class as a numerical variable, it would have given something like this, 2.5, 2.0, 1.5. It wouldn't have treated the variable as a proper categorical variable. So with this code above, so suppose that you have transformed P class as a factor variable. With this code here, you would get this bar chart, this stacked bar chart. You can have a Dodge position, so Dodge bar chart. You can have it like this way, and you would have the count here, the number of passengers in the y-axis, same as the stacked bar chart. It's just that instead of having them above each other, you would have them aside, okay? And of course, you can add the number of people. You can modify the label of passenger class. Again, the most important, the emphasis in this course is not exactly the code or the software you're using. It's more like to understand what you should represent what you should use as graphs to represent, for example, the distribution of a categorical variable like P class, okay? So here we have a Dodge bar chart. The other one was stacked. We can call the Dodge bar chart as unstacked bar chart as well. And you can also represent the categorical variable as a pie, okay, with percentages. So for example, so if you need to convert, of course, this data set that you have created to put like the percent, okay, the percent per category. And you would represent a pie chart just by running this code, okay? You would have the third class would be the mode of the category, and passenger class would be represented by this pie chart, okay? So the pie chart is more to represent the percentages, okay? The distribution, okay, of your categories. So it is always better to use percents to represent the distribution of a categorical variable because you have more an idea of what proportion it uses, okay? The mode is the most frequent category, and this is basically the descriptive statistics that you would use apart from the percentage per category. But I want you to understand this that you can still use the counts, okay, but percentages, it's normalized all the counts compared with 100, with the number 100. And so with percentages you are more able to see which category is more frequent. I mean, it depends, but usually we prefer to represent the percentage. Likewise, you can transform your bar chart with percentages as well. So instead of the counts here, you would get the percentage. Anyway, feel free to ask any questions, but as descriptive statistics, apart from percentages or counts per category, we represent the mode, okay? The dispersion is really just, you can see the dispersion or the spread by looking more at the pie chart or the bar chart, really. It's more like a visualization, a visualization task than getting a number like for continuous variables such as the standard deviation or the interquartile range. So there is not much really to know about the distribution of a categorical variable. Maybe for ordinal variable, you would use a bar chart with, because you have a meaningful order. So the x-axis would be the meaningful order from strongly disagree to strongly agree. For a pie chart, maybe it's better to use it when you have a nominal variable, but it depends more on you. Anyway, in a pie chart, it's more the percentages that are represented because the pie, the whole pie is 100%, really. Okay. So I hope you enjoyed the video, and don't forget to subscribe, and please put your comments or send me an email to the that is in the comments below if you have any questions, and hope you enjoy it, and I wish you a very good day or very good night. It depends. Okay. See you another time.